So let me just, for the audience, quickly introduce my panel here. I've got Dr. Lon Gowen, who is Chief Data Officer in the Countering WMD office within the Department of Homeland Security. I've got Mark McDiarmid, Senior Vice President of Radio Network Engineering and Development within T-Mobile. Steve Orrin is the Chief Technology Officer within Intel Federal. And Tony Smith is Director of C3I, the Office of CIO, Department of Defense. And so thank you all, and I appreciate your time today. So let's start with some questions on the emerging opportunities. Commercially, 5G is hailed as enabling all sorts of new high bandwidth, low latency services that open the door to apps like virtual reality, autonomous systems, smart industry, et cetera. Many government specific use cases can take advantage of these emerging capabilities. And from previous, our polling showed that a lot of the government sectors are really starting to latch onto and progress into different 5G scenarios. So I'd like to start with just a question, given the backgrounds of our panel here. What are those government use cases that you're seeing now to emerge as potential opportunities? And what value really does 5G present to those agencies, whether it's cost reduction, greater efficiency, or really enhanced capabilities? Let me just start with Steve. Why don't you, as Intel Federal Lead, give me some insight on that, and then we'll let everybody follow up with contribution.
Sure, and thank you for having me here today, Dustin. I think we're seeing a lot of innovation and projects starting to gear up around 5G, and it really does cut across a lot of those examples of the value, whether it be sort of enabling the next generation smart base and for sensors across space and logistics, maintenance to be able to interoperate and communicate with each other in real time, to for deployed use cases, ISR, being able to do video surveillance, intelligence gatherings, all sorts of IoT style use cases at the speed and at the scale that you really want it to be. 5G really is that technology that opens the door to the promise of these other technology innovations around AI and IoT that we've been hearing about for some time, we've seen in small scale. 5G is the technology that allows that to open up. And so we're going to see it permeate all aspects of government, both civilian and military, as it starts to enable all those use cases that everyone's been talking about around better intelligence gathering and surveillance, around supply chain and logistics management, being able to get real-time response from the plane of what it needs, what part needs to be fixed before it even lands, and be able to get that information and then to have the logistics supply chain come in. So we're seeing all these really amazing use cases and applying AI at the edge and then being able to communicate that to other entities, other devices, so they can respond. So I think what we're seeing is the promise of the technology transformation being enabled by the 5G technology and standards that are being deployed.
Excellent. Does anybody have any follow-up with that?
Yeah. Hey, Dustin, it's Mark here. I could pile on it and add to Steve's comments. Certainly, there's a fairly big, a broad dialogue going on with the US government about use cases. And I would say one of the biggest themes we're seeing is to really leverage 5G's low latency capability, taking certain applications that benefit from low latency and moving them out of the cloud, which is very centralized, to the edge. And we've all heard a lot about mobile edge compute, but hosting application servers and clouds for customers in our data centers right next to the radio is how we're doing that. So we're actively engaged with the US military, all four branches of the US military, in exploring those use cases through the pilot program initiatives that are underway. So just very exciting to see that happen.
Dustin, if I could jump in as well. From the DoD perspective, we kind of have two broad use cases. We have the combat use case, what are our warfighters going to use it for? And we also have the day-to-day operations. What do we do at the 1,000+ installations that we have around the globe? One of the biggest use cases I can see is all those installations at some point in the coming years are going to have to replace their ground fiber, and we even have copper cable infrastructure out there, and we can see just from an efficiency standpoint, being able to use 5G to replace a lot of that legacy infrastructure that's out there and do it a lot cheaper. A lot of people would estimate that the Department of Defense spends in excess of $40 billion a year on IT infrastructure. So that puts in perspective how much stuff we have out there. On the combat side, today we have lots of different, stovepipe networks to share ISR information from a sensor to a ground node, and then we have to have a whole series of relay systems to go between line of sight systems and beyond line of sight systems. And some of the stuff I'm looking forward to from T-Mobile and some of the other big vendors are linking the satellite low Earth orbit constellations that are going up now with the line of sight, cell phone kind of networks, to where, a warfighter can take his tablet off his desk in a home station. He can hop on an airplane, fly to a combat theater with that same system, use it in flight, talk in flight, get updates on mission information and updates on intelligence. When he hits the ground running, and he's using the same system when he gets to the other end. And then all of our data links and everything else could potentially use the same core system. So instead of having 10, 20 systems doing this, we can narrow it down to just one kind of overall service that we're providing. And then, oh, by the way, on the Department of Defense, our mission is even more complicated because we have different layers of classification, and depending on what coalition partner we're working with and what application you're using. You have secret, top secret, special compartmented, all that. And each one of those have that same stovepipe infrastructure. So take the 15 infrastructures I talked about before, multiply it times 4 and 5, and that's how we get to $40 and $50 billion a year on IT expenses.
Interesting. So it sounds like from a killer app standpoint, there's a broad spectrum, right? From a cost reduction angle, simplicity, and enhanced feature set, kind of all built in to the functionality of integrating 5G into a lot of these use cases. So I think from the standpoint of moving to the next topic, I'd like to cover the concept of public and private networks. So as we look around, there's a lot of discussion around large-scale municipal and government-owned 5G networks. So kind of moving into the space where now the networks may be owned by government entities. For example, some of the smart city efforts that are underway, to subsidize underserved neighborhoods, et cetera, kind of rolling out different types of networks for the purpose of, public utility. To do so, features such as neutral hosting and multi-tenancy are kind of building into these ecosystems to allow different users or customers to operate on the network. I'm kind of curious from this audience's standpoint, what role do you see, kind of private 5G networks kind of playing in the future department and agencies of federal government, state government, local government, and how does that going to evolve really? Let me start with Mark. Why don't you contribute to that one?
Yeah, thanks, Dustin. Yeah, very, very hot topic without question. I think the opportunity, if we think of private networks, what does it, definitionally, what does it mean? And how would the US government benefit from such things? Well, I think the first thing to recognize is the promise of private networks really is around owning and controlling your own bandwidth and where the data and information is stored. So that there's a way to actually compartmentalize the entire network under governance, which can have its own levels of security built in and operated within. So that's part of the promise. I think the piece that's a little bit yet to be discovered is the level of complexity around what it takes to operate these networks. So, part of the burden of experience that I carry around is the level of complexity is challenging. But we are working with industry partners to bring solutions to bear which have shades of complexity built in or to give flexibility, or in some cases simplified all the way down. But many of the use cases we see with the US military, we see use cases where data sovereignty is absolutely required, and there's no concept of connecting anything in this private network to the public network or public highways. So there's a way to do that and compartmentalize completely, which is very valuable. There's also a way to share radio infrastructure and core infrastructure in such a way that you can bring public service, public access for people who may be on the base or contractors moving in and out of the base. And that can be separated and compartmentalized in a secure way as well. So a lot of opportunity there, and we're certainly seeing high levels of engagement from at the DoD on this right now, which is very exciting.
Interesting. So that'd be one question for you, I guess, Tony. Is that something? Is that a part of your office's involvement, or in terms of what sort of planning may be ongoing for these sort of situations?
It sure is, and a lot of what I've done over the last couple of years, we're trying to outsource a lot of our base infrastructure in the United States to start with, and go to commercial vendors. Right now, AT&T taking over a couple bases, Microsoft's taking over a few bases, and we're trying to figure out how to do as a service, so we can focus our efforts on actual warfighting capabilities and not having to do just day-to-day utilities. And Mark, you hit the nail on the head. We love our data, and you could think that the DoD is probably, when the Chinese and the Russians and others put their attack list together, we're probably at the top of that list. So we really have, we're security conscious to the nth degree, and so protecting the data, not letting even our simple unclassified data get into the wrong hands, because that can be compiled and used in ways against us. And then the other bit about vendors working with us, we have a trust but verify approach. So we won't let you just take over as a service and then show us all your security controls and say just trust us. We have a want to actually do some independent assessment or third-party assessment of your security. So we're bringing the best red hat guys, and we'll try and crack your system periodically, either no notice or notice. And we want you to at least prove to us that you're maintaining these security controls continuously. And that dealing with vendors, that's there's a lot of arguments about how far we can go, because obviously when we do that, vendors are concerned that we're potentially mucking with their commercial business as well, and looking at their private activities as well. And so there's a natural tension there. And that's one of the things we'll have to work out with vendors in the future, as we do as a service, is how do we do a trust but verify approach? How do you allow us to bring some of our tools to bear to see how well your security really is? How do we verify your supply chain within that too? Because some of the products that we found with some of the as a service offerings don't have the greatest lineage, even though the prime vendor is trusted, and we would put them above all else. But some of the products they end up using, as you peel the onion, you find out they aren't quite as clean as they should. So,
any other comments? Steve, did you have something?
Yeah, I was going to say that to both points, the part of what the industry is doing, working with the federal government on the implementation, on the technologies that are being inserted into all aspects of the 5G infrastructure, are going to enable some of those use cases, whether it be technologies to do hardware-based isolation and segmentation, as well as the verification of those workloads, the virtual network functions, so that you can operate in a public-private style environment where you can bring the public infrastructure and be able to do private networks that come and go as needed. And when you hit on the data sovereignty, that's a really key point, being able to make policy decisions about certain data and certain workloads that can take advantage of public infrastructure, and some that should never move off of your private infrastructure, and be able to implement those policies, part of the natural orchestration that goes into deploying assets across the virtual and 5G infrastructures. Those building blocks are being built in today and have been for the past couple of years. So as these technologies start to roll out and mature, you're going to start to see the DoD and the public sector working with the broader industry to be able to do these kind of complex use cases that leverage both public and private networks, as well as ad hoc networks that come and go as needed. There are some really interesting use cases about being able to pop up a really secure private network overlay on public infrastructure for a particular use case, whether it be event protection, in a DHS perspective, or port security when Navy comes to shore, and be able to take advantage of some of the public assets that are available while still maintaining the security that you have and you require for your assets as you take advantage of. So there's some really advanced technologies that are being implemented. And I think what the exciting things is, as opposed to other technology revolutions where it was always security was an afterthought, we're finally at the point with 5G where we're saying security has to be built in from the get-go. These foundational features have to be there and be part of the standards, so that these new use cases can be enabled and that we don't come back later and say, oh my gosh, what did we forget to do?
And certainly security is a hot topic, if you were listening to the prior fireside chat, that was, I would say, over half of the discussion was evolved around supply chain and security and all the other concerns, which we can certainly get into. I was hoping to not drive us into that conversation initially, as I feel like we'd spend the entire hour talking about that one topic. So I appreciate your contributions there. We'll get to that, but I want to make sure we get through some other stuff. Lon, did you have anything you wanted to contribute on this topic?
Yes, thank you, Dustin. Quickly, I mean, I think between Mark, Tony, and Steve, they've covered it really well. I mean, the point, just to drive it home a little bit, is, at least from my perspective, we build a lot of these campuses, buildings, and things like this, where we put in all this wire. You know, you could just imagine a 12-floor building in downtown DC, where we're running, you know, cat wire all the way over the place for Ethernet and things like this, versus the idea of where I think we should go is where it's just completely wireless, and we have, and 5G, as well as, you know, advanced 4G LTE and things like that, private LTE. Those are avenues for achieving that. And so I see 5G as a big leap potentially to make that happen, and to be heterogeneous, you know, so you can just, you know, run things either to the roof or to the, you know, to the basement, so to speak, the ground floor, and hook into any service provider and basically have your kind of private network that's all wireless. And to go to, you know, Tony's point earlier about, you know, having you know, somebody from the military be able to grab his laptop, leave home, jump on a plane or a ship or a train, whatever, and head out. That idea, as they leave the house or leave the building or leave the base, and have that connectivity just be seamless, is really good. So, I mean, that's some of the stuff I look for as I think about campuses, and we have, I mean, within Homeland Security, as everybody knows, I mean, there's, you have TSA. So just think of every airport, right? And being able to have 5G in those airports, and being able to, set up your infrastructure over and along with, a public network as well, is going to be really important. So anyway, back to you.
Yeah, no, thank you. I think that the discussion here amongst the group was sort of that ubiquity and universality of the connectivity. Of course, when you talk about all these new and interesting, we run into the problem that we only have so much spectrum. So I'd like to have a quick dialogue about spectrum sharing, because that's going to be one of our biggest challenges going forward. And so, looking at spectrum management traditionally, at least from a commercial mobile network standpoint, it's been very rigid and static, right? You get a little window and that's all you get. You got to stay in there. And if you go outside there, you're in deep trouble. And spectrum's expensive and it's scarce. And so there's kind of a limitation to who can get in, and competitiveness is limited by the fact it's a scarce resource. We're now working in a lot of new and interesting ways to try and be dynamic, we'll say, from unlicensed 5G bands, coordinated spectrum like CBRS, where we talk amongst ourselves to figure out how to share, dual use such as FirstNet, this kind of ideas of being able to create modalities within the different spectrum. But conversely, sort of the US government use cases, a lot of them have been previously allowed to use a lot more of the spectrum, are now shrinking in terms of their domain or sphere of frequencies they're allowed to use. In order for our agencies and departments to really retain their flexibility, they need to be able to operate in a much more agile way, right? DoD can't be regimented to small slices of frequency bands. When adversaries know you're there, it makes it very easy. And you can talk about other use cases beyond that, where that flexibility and agility is really important. So I guess the opening salvo of questions is, what can we do about it, right? There's a lot of ways to play this out, and how are we going to go about going forward to solve this problem?
I'll jump first, if that's all right, Dustin. So, we have with 5G an experiment underway at Hill Air Force Base right now, where we have radar systems that are there, and radar is one of those high demand pieces of the spectrum that the 5G world is trying to get their hands on. And so, wherever, we're continuously getting requests on, why do you need all this bandwidth? Why do you need to cordon off this? And it's just, we're one administration away from taking that bandwidth away from us and forcing us to go figure out how to do radar in an entirely new way. So the test that's at Hill right now, we've got 5G systems working in parallel with some of our radar systems, and we're trying to use AI to figure out how to, do directional kind of nulling, to do other automatic capabilities to where the two frequencies operating in the same band can cohabitate together, and the 5G is not interrupting the radar system, and radar is not wiping out the entire 5G network. So we're running that test right now. As a useful anecdote, years ago, I had to support a Secretary of Defense forum in Colorado Springs. And so we had all the Ministry of Defense come in to that one small area at the Broadmoor Hotel in Colorado Springs, if you're familiar with it. And at that event, we had to set up an entirely new cell phone system, because all those people and all their entourage just wiped out that particular local area. Well, the cell phone system we set up, a tactical system, broadcasted such a high power that all the locals were complaining that the garage doors were opening and closing continuously during the entire event. And as the lead communicator, I had to spend half my time trying to track down what was causing it, why we were doing it, figure out how to work around it. So those are the kinds of things you run into, especially between military and civilian applications. And we're working right now to, at least we see the writing on the wall, that we're going to lose more of our spectrum in the DoD. And we're trying to figure out how to, cohabitate with the commercial marketplace.
Yep. Hey, Dustin, maybe to add to Tony's very salient points here, I think this question of coexistence, a couple of comments. One, we absolutely need to, as commercial entities, work more closely with the US government to find ways to make spectrum coexistence work better and more intelligently. And Tony, you spoke well about that. Thank you. So we're fully committed to that. I think on the flip side, the opportunity with 5G, and certainly it started with 4G, but now central to 5G, is depending on the use case, it may be such that the use case is best served by multiple frequency bands being used simultaneously. So we use techniques like carrier aggregation between bands. We can do aggregation between 4 and 5G, or we can operate 5G on its own standalone. And I think this is the opportunity that we see at T-Mobile to step up to the plate to figure out how do we help government agencies achieve 5G reliability and bandwidth that's needed. So one of the strengths that we bring to the table, we feel, is that we know how to make services run as efficiently as possible. And we constantly are commercially motivated to figure out how do you get more out of the spectrum you own. So we're constantly focused on that question of efficiency. And I think we can, the opportunity in the partnerships to share and learn, but to coexist as well.
Yeah, no, I think that's, as you mentioned, a challenge going forward. I know that it's being addressed as we speak. The National Spectrum Consortium's got ongoing efforts to solve the spectrum sharing challenge, and I know it's been invested in heavily across the board. It will be a continued challenge as we move forward, but I'm encouraged by the fact that it's being thought through from the standpoint, not only from a commercial endeavor and multi-band and channel aggregation approaches, but also from a ability to coordinate sharing across different endeavors. So, I'll be interested to see how this progresses in the coming years and how the standards can evolve to accommodate that. I guess to sort of transition us to the next topic, which would be standardization, interoperability, spectrum sharing being one piece of those. One thing to note is, the government is eager to adopt solutions that are based on commercial standards because they get to leverage economies of scale. It makes sense. However, those standards are often somewhat incomplete in the sense that they don't address the full government's specific needs. Identically, this government has a lot of its own standards. For example, the MIL standard, there's a whole lot of those for addressing kind of what the military wants to see and how they go about doing business. But those rarely get incorporated back into commercial standards, whether it's cost or whatever, that they don't necessarily blend together. The government has a lot of means to promote solutions that do address its requirements, whether they get involved in, commercial type industry efforts, TIP, ORAN, et cetera. They can, create some emphasis there. They can do direct sponsorship. For example, DARPA, like Ops 5G, is an effort to try and bring together government interests to evolve kind of open interfaces. How can the government incentivize commercial industry standardization to incorporate its use cases into the path forward?
Hey, Dustin, this is Lon. I'll take that one first, if you don't mind.
Sure.
So one of the things that, I've been looking at recently, simply because it's kind of, we had the cloud first idea, right, which came out from Vivek Kundra, back in, around 2006 timeframe, if I remember right. Well, we got something similar. There's a, what I like to call a meta standard that's working its way through the government, especially within DHS and also within DoD, Joint Staff J6. It's called NEAM, the National Information Exchange Model. And I think right now the PMO is the Joint Staff J6. Previously, it was Homeland Security. And it's a very interesting approach that seems to allow domains to exist, and such as 5G or CBRN or you name it, right? Immigration, all this kind of stuff. And the whole idea gets into information sharing and information exchange and be able to do that smartly. And it requires standards like we're talking about, but it requires kind of a model or an approach like what NEAM is trying to do, that allows multiple standards to be able to be kind of absorbed into a governance model and then shared out to systems to make use of that. So that, what I think of as maybe a CBRN event is not necessarily what, DoD thinks of, and all it takes is for one data type to be a little different, right? I require a 9-digit, zip code. Somebody else requires a 5-digit zip code or whatever, those kinds of things. So it's a very intriguing idea, at least for me, from a relatively new standpoint. And I know NEAM's been around for a while. It's not new, but it's gaining a lot of headway. And it's something I'm looking forward to from a standards perspective, because as CDO at CWMD, that's one of the things that falls into my AOR, right? How are we handling standards? We have to report these, back to Congress every year, right? And like you mentioned, it's very important that we work on these open standards and things like this with, the private sector, with other public sector entities. So it's kind of my quick thoughts on that, and I'll hand it back over to you, Orrin.
Okay. Yeah, one thought I had was that from a commercial standpoint, the carriers have been busy in a lot of these interoperability, and I'll call them plug fests, where a lot of technology is put together to demonstrate interoperability. And I'm just curious if there are any thoughts about how the government may incorporate some of that thought process about these open interoperability testing scenarios where the vendors are kind of allowed to demonstrate their capabilities as a way to facilitate that promotion of interoperability.
Yeah, I'll throw something on the table, Dustin, on this topic. It's a crucially important topic. I think there's been a lot of progress made over the last few years about how to say it, managing certain vendors out of the ecosystem inside the US. Mm-hmm. And that's been tremendously helpful, because then, as we show up to do interop testing with partners, there's no fear or concern about somebody being in the room that shouldn't be participating. Not naming names, but we all know the short list of unfriendlies, right? So I think creating those safe environments, I would say it also has to extend into the research and development community, and specifically research and development in colleges and higher ed. And I think there's an opportunity there to clean up some of the funding and manage some of the participation from certain foreign nationals in those activities, to ensure, again, that standards are created that are truly US-centric, sympathetic to the use cases that we need, and not suffering the risk of any pollution from foreign influence. So the research and development space is an area that the US government traditionally hasn't played very heavily in, but funding and regulation and governance could do a lot in that space, I believe.
Dustin, if I could add to what Dustin or what Mark and Lon mentioned. So the entity that you talked about, Mark, that we tried to weed out of our standards development here is heavily involved in the international standards front right now. And in order to counter that, my office deals, we have our own federal consortium, so we work with Department of State and DHS and others, but we work with NATO, and we work with a lot of our other coalition partners, say South Korea, that happens to have, a Samsung as a key contributor to 5G. So we are working our international military partnerships to help facilitate, dealing with some of the key vendors that we think will help us overwhelm the bad actors that are liable to develop, less than optimum standards for us to go forward. So, there's a serious tennis match underway right now with, both sides firing for effect, but we're doing everything we can. And when you get into the ITU and the 3GPP forums and so on, it all comes down to how many people are on your team versus how many people are on the other team. And so we're doing everything we can to, at least when the final vote's taken, that we have enough of a vote to overrule some of the, rather ridiculous things that are happening on that front. On the research side, we're investing, a couple $1 billion over the next couple of years doing various, test activities with different 5G things, whether it's supply, inventory and what I already mentioned with spectrum deconfliction and virtual reality with our training and lots of different activities where we're trying to match specific government and DoD requirements to how the commercial technology can interface with that. So we're spending a lot of money. We have a lot of RDT&E money underway right now. There's a lot of we're talking about starting up another tranche of money next year as long as our budget doesn't get cut too much to go into even more activity. So any 5G vendors that are out there, the door's open. We're looking for lots of work in this area.
If I could just add to that, I think what we've already seen coming from DoD and the tranches they've done is creating these test ranges at various different locations across the different services, so Navy, Air Force, and Army, that is allowing for a coalition of vendors, both large and small, to bring their technologies to bear and put them into real, into a live environment to be able to test this stuff out and be able to show, can they use various different technologies together to meet the mission needs? So we're seeing a lot of great activity there. And the other interesting thing, because 5G is a new spectrum, having a safe place to go turn on these things and have that signal without, like you said, interfering with locals' garage door openers has been a way for allowing the smaller companies that don't have the facilities to innovate, to be able to go off and do that with the U.S. government. So there's been a lot of exciting work there, and I thank you, Tony, for doing that. The other thing that I think is interesting, as you mentioned around standards, is we've seen NIST step up its game here as well, not only developing standards for the government itself, but also partnering with the international community, with the ITU, with G3GPP, to make sure that they're, through the standardization process, that input is going in. And so again, as you mentioned, the standards are created by those who show up, and we've seen NIST double down to help get more involved on the international scale. And I think that's the call to action for all the vendors and for the agencies, is the more people who show up with our mission, the more that we're going to be able to get a voice in those rooms across the board. And we can't just be locally focused. We have to think about the international standards community.
Absolutely. And I guess we've talked about, 5G and 5G networks, but intimately tied to that is really the idea of edge compute, right? A lot of the value comes from when we take the cloud and push it out to the edge. That migration to the network edge, comes with pluses and minuses, right? So we used to have all of our data locked up in a fairly small number of rooms in these hyperscaler cloud environments, very secure, small number of places. But now we're basically flipping that whole thing around, and we're taking all our data and just sprinkling it about. The previous fireside chat actually touched on this a little bit in terms of mitigating techniques such as tamper-proofing and encrypting data at rest. Various techniques one can do. But arguably, we've got a bigger problem now with, for example, managing PII and privacy concerns, which I'll be honest, I didn't think were all that well managed until the government kind of stepped in and forced the hand. Now we've got that in a whole nother dimension, right? We've got basically an exponentially harder problem, and the little smatterings of private information is going to be out in the environment if you think about that. So I guess the big question is, what is the government's role in terms of shepherding a policy around data management? Is it left to private industry to manage this on their own, or is there some need for us to start cultivating an effort to consolidate what that means in terms of public right to privacy and how that evolves into the edge compute scenario?
I'll jump in on it first and let everybody else weigh in. So 5G and IoT, the Internet of Things, provides a lot of benefit. I mean, it's going to, as the congressman and others mentioned in prior discussions, I mean, it's going to change the world. And so every country and we need and are trying to help lead that effort across the globe. Just being able to enforce the security of these things is something that's a huge concern to me, and I know it to many people, because it does get into the privacy of things. I mean, we still walk into pharmacies today, or at least I do, in the DC area, and what's the first question they ask you when you step up for a prescription? What's your name and date of birth? I mean, they just ask it right out in the open. Those are, I mean, really, so in some areas of our country, we're still way behind in how we handle privacy. And now when we bring in 5G, where we're going to have things at the edge, maybe taking video of, somebody crossing a border or video at somebody at an airport, and things like this, where are those barriers? And I think, the federal government, I think, is taking a pretty good lead on that part of it, from the privacy perspective, from the data perspective. I mean, NIST, we've talked about NIST, right? We've talked about, their risk management framework. I think Tony mentioned that right off the bat. So these things, I think, are there. They're going to continue to get better. But it's all the things that don't have to follow NIST, right? Or don't have to follow good security standards or approaches and policies, right? And that, is probably a topic which is going to come up in a little bit, but that gets into the supply chain thing, right? But more than the supply chain, it gets into, it could be somebody here at, in the US that manufactures a bunch of IoT devices for your home, right? Somebody hacks into those and does what? Guess what? They lock all your doors. They turn out all your lights. They start your car. While you're traveling down the road, they turn your car so that you crash, right? All these, they change traffic lights, so they're green all direction. So as IoT gets more and more embedded in society, there's a lot of benefit, but there are a lot of things to watch out for, like you mentioned, and that's the security piece. That's a big concern to me. So I'll pause there and hand it over to others. Over.
I could add kind of one more thing to the whole data element, data strategy. One of the things that DoD does really bad is tagging its information. We have thousands of units in the DoD, each have their own independent mind on what's classified, what's not, what is private information, PII, and they all do a very poor job of either we overclassify or we underclassify, and we're constantly, having issues with that. And I think, when you allow so many people make a subjective judgment like that, you're bound to have problems with that. And oh, by the way, we're going to have to get better at tagging, just because the whole zero trust environment that they're talking about for cybersecurity relies heavily on our ability to tag the data, the tagged applications, that segment our networks, all that. So I think AI and from the commercial industry, artificial intelligence enabling us to automatically tag a lot more stuff is where I see this heading, because we got to take it out of the human element as much as possible. That there's always going to be times where some human is going to have to be, an overall cyber classification czar to check our homework. But ultimately, if we can say, and we're already doing it with our sensors regardless. So, if it sees a particular, 9-digit string or 10-digit string, it's like, hey, this might be a social security number, block. It's not going to go through this particular firewall. So we already do that to a small extent, but I think AI in the future will help us if we can build the appropriate algorithms and rule sets to automatically tag information, and then we can start protecting it and then building better cross domains and better, ways of either sharing or blocking that information.
You make a great point there, Tony. And I think going back to something that Lon said, And when you add, Dustin, when you talked about how does policy and what can the government do, one of the key things that we've seen often is that policies come out on yesterday's approaches. And I think one of the things, it's in the title, edge compute. We shouldn't be trying to figure out a policy of how do we secure all this data and how do we correct privacy into the cloud. We should think about how people are going to operate these systems. The whole point of 5G is to be able to push that compute and that processing and that decision making right up at the edge, right into the sensor. And so if that's the way that's going to be used, maybe the better approach is don't let the PII leave the sensor, let just the intelligence you've gathered. So it would reduce the overall burden on security if I didn't have to send all that data back in to then secure it for the broader infrastructure. If I could apply the security controls at the data, at the point of acquisition or at the point of consumption. And we can do that now because the 5G and the edge compute capabilities enable us to do real processing and to perform AI at the edge. We can now protect the data where it sits and also get rid of it, or at least make sure it doesn't leave the system unless it absolutely has to. And by doing it that way, we reduce the overall burden of the entire infrastructure having to be super secure. I can focus on the things that are actually touching the important data and then leave the rest of it out of the trust boundary. And so as we start looking at policies that come down to dictate how we do security, we should think about how this stuff is being deployed and not try to use old security models for the new security approaches.
Hey, this is Lon, real quick, to bounce off what Steve's saying, where that's doable, that's great. I think, matter of fact, we've been looking at that in some of our systems here. And I apologize for any background noise. So it is really important that the concern I have is that as long as we can do that bit of analytics at the endpoint like that, that's great, and we should, because it does exactly what Steve says. It is going to allow us to provide an answer on something without necessarily, transmitting images that may be PII related or things like that. So that's where the horsepower of processing and artificial intelligence, machine learning, all that kind of stuff can be a big benefit. And as far as I can tell, we're still following Moore's law pretty closely. I mean, I keep seeing compute power and everything increasing, and a number of CPUs that we can crank out on a wafer is getting quite large. And I think that'll continue. So as long as that continues, I think we'll be able to achieve exactly what Steve's trying to get at. Back to you, over.
Well, I think you've all pointed out some very important facets, which is the temporal and locality nature of the data, and as far as what constitutes it being sensitive, right? If it's something trivial like opening a door, it may not have that much value until I can associate it with somebody's motion, knowing where they're going and who they are. So if we can find reasonable ways to limit the scope of the information in a way that we understand the context that it's in, again, a very complex problem, because as Tony was talking about right now, it's basically a person making that decision. But if we can find ways to really scope data in a way that we understand the liabilities of it, we can apply that model to the edge compute component to protect data as it's needed. I think that's an interesting way to look at the problem, and I'm sure there's a lot of additional work that we've got to pursue in order to make that happen, but certainly an interesting angle. All right, well, I've got one more topic that I know we have to get into. It's the one that everybody always wants to get into, which is related to security, right? I wanted to sort of touch on it from a slightly different angle. We had talked about supply chain integrity a little bit in the previous discussions with the fireside chat. I wanted to talk about it maybe from a slightly different direction related to we'll say that the pains that a lot of us are having from the electronic component industry status. Shortages of parts, just can't get stuff to fill our product portfolios. We can't sell stuff we can't build. A lot of that has come about obviously due to the COVID phenomenon and slowing down of things, but it also just comes about from the fact that we are a global economy. Everybody's competing for the same parts, right? We're not just buying parts from the US, we're competing with everyone else in the globe trying to get stuff out of silicon foundries. So that links our economy, our US economy, very tightly with the world's economy, or I should say that the challenges of global infrastructure. And so the thought process being, as was discussed previously, we've decided that it is in our strategic best interest to put forth an investment into regaining or recapturing some of the silicon foundry capabilities domestically. What other facilities or aspects do we think are relevant to bringing as a strategic asset of the United States, such that we can decouple ourselves somewhat, at least from the pain that we're now suffering from the standpoint of this global shortage?
Hey, Dustin, I'll jump in maybe and
Yeah.
kick the conversation going. I think the sort of situation that's occurred, you're quite right. I mean, some of it's driven by COVID affecting manufacturing capacity, but the other side of COVID that we observe is that, consumers who've been forced to work at home throughout the US and across the globe have been avidly upgrading their home infrastructure. And that too has created a burden on router technologies, router chipsets and Wi-Fi specifically. The piece about natural resources that's hard to have a discussion about, but super important, is about the mining of rare earth metals. Because certainly the silicon piece is a key component. It's something that as a nation we offshored many years ago because it's practically a very dirty and environmentally difficult manufacturing process. But we have to bring it back, and we've got to figure out how to do it clean and do it right and do it in a way that supplies the US ecosystem. But yeah, mining operations are almost inevitable, I think, because of the stranglehold that China has on the manufacture of rare earth metals. So that's a topic that we're going to have to deal with.
I think one of the things, and we've seen this in some of the recent events in the DC area with the administration, it's getting collaboration amongst the different industry partners to help enable that ecosystem and getting frenemies together so that we're co-developing and co-building solutions that enable all the different verticals in the United States to, again, help not only fill the supply chain, but help deal with that fragility that we have and that we saw in the time of COVID. And I think what we're seeing is the U.S. manufacturing industry and the U.S. semiconductor industry are starting to work together. The technology industry vendors are working together like they haven't in the past to come together and try to figure out how do we solve this problem. And so you've seen commitments from all the big players over the last several weeks that we're all in on this and we're all going to make this happen. And then the ball then comes into the government's court and others to make sure that they're specifying that we need to have US-based technologies in the supply chain, and that they're going to help enable the industry, both small and large, to take advantage of that supply chain, whether that be through funding, through policy, and through other incentives. So I think we're going to see a variety of approaches to help make sure our supply chain is strong.
So one other element of this is, the various nation states are subsidizing key elements today, whether it's backup software or antivirus or other computer chip. And as they subsidize, they obviously make their products cheaper to, especially, some of our third world partners and other countries around the globe that are looking for cheap stuff and so they'll instantly buy the cheap stuff and then find out that their infrastructure is now owned by a foreign power. And the question, I guess, within the United States is, we're obviously in a capitalist economy, not into totally subsidizing our vendors to build things cheaper. It just runs anathema to what we do. So are there other avenues we can help sponsor our vendors without, wholesale, just, providing significant amounts of government money to fund their activities?
I was just make one final point there to your comment, Tony, and that is, basically our strategic presence in 5G, as you mentioned, that it is not a US specific endeavor. This is a global thing with respect to both allies and adversaries kind of investing in the future in this global digitization process. And by essentially subsidizing equipment moving into primarily developing nations, how they're rooting themselves into kind of being at the core of that developing nation's future. We as a country have to decide whether or not we want to counter that or otherwise be part of promoting those developing nations to have freedom outside of their dependence upon those other entities. So I'll leave it as big picture. It's a very sensitive question, of course, but it is very important because it has implications that last for decades. So Megan, I'm going to let you go ahead and turn us loose on question and answer at this point.
Thank you, and tremendous panel so far. This has been excellent. We did get some great questions from our audience, so I just wanted to pull a couple of them. But we did have a couple of questions around, 5G and all of the data that's being collected, especially around edge computing. And so one of the questions was, are there opportunities where we can use 5G to move terabytes of data captured by IoT devices to either on-prem or to the government cloud? And a secondary kind of question around 5G and data is just how do we better prepare government personnel to deal with the influx of data coming in from IoT devices?
Megan, maybe I could offer some comments on the first part of the question. 5G definitely can be used for moving terabytes of data around. And we've got consumers who run households that move terabytes around routinely too. So I'm sure if that's the case, we can do it for the government too. It really comes down to two things. What's the cost of moving that information from one place to another place? What's the value of the information underneath that? And what's the economy in terms of applying processing resources at the edge to deal with that volume of data? So, one of the great examples that has been discussed, security cameras. So imagine a situation where you've got security cameras observing a base in the US or abroad, and those cameras are running at 4K resolution, but there's a machine learning algorithm that's doing face detection, looking for certain individuals, I don't know who, but that can be done at the edge. It could be done in the data center nearby, a few miles away. It could be done on the base, on a radio base station, and it could be done on the camera. And it's simple math in terms of business analysis to figure out where's the most economic place to deal with that. So yeah, 5G can do all of those things. The question becomes, what's the most economic path to getting that done? And how do you respect all the security and personal information policies that may be in effect too?
If I can add to that, and you bring up a great example, surveillance cameras is a really good one, is that I think that the notion again is that we don't need necessarily to move 5 terabytes, all those terabytes of data to a gov cloud or onto an on-prem data center. What we need to be able to do is extend those clouds to the edge, push the application, the machine learning, the facial recognition application as close to, if not in the camera or right up next to a group of cameras. And really the only thing you want to know is what was the face that was recognized. You don't really need to see the raw image, maybe a snapshot of the face, but the 20 minutes before and after, no one cares about. And again, you can reduce the load by pushing that application functionality to the edge and then only capture the interesting bits, if you will, and transport that. So it's not just about can we secure the information, but can we do the data minimalization so that you get the better efficiency out of your cloud infrastructure. And what 5G does is with the mobile edge computing capabilities, it allows you to extend your cloud or extend the on-prem data center functionality right up to the pointy edge of the spear. As Mark was saying, and be able to do that facial recognition, that change detection, that object recognition, either in the camera or right up next to it on the, close to it. And therefore you don't have to figure out how to move all that data. You just have to figure out how to get the intelligence to the edge.
Yeah, I would put it in terms of the maturity of the problem you're trying to solve, right? The first thing I do when I debug something is I capture all the data because I don't know exactly what the question is. So I want to save it all and deal with it later. That's, step one. And that would be, in this case, I would take all that data, I want to move it into the cloud. But the better I get at asking the question and knowing what I want to get out of it, the more I can toss off all that stuff that I don't care about. So I think it's an evolution as we get to the point where we trust and understand the questions we're asking and the answers coming back that we have confidence in, we can do that job of getting rid of the information that we don't really care about.
Yeah. Hey, Dustin, just to put a little color in it as well, of course, the surveillance example works for distribution of compute, to the edge simply because it's a static use case. But the flip side is if we were operating video cameras on a military vehicle in a test range, and it was mobile, we'd have to deal with the reality of we could only distribute the application so far down to the edge, because the more distributed it becomes, the more frequent it would have to be relocated as the device and camera move. So this question of relocation of applications is something we've been working pretty avidly on at T-Mobile, and certainly as part of the pilot programs we're exploring with DoD. So that's a lot to learn there, but there's some cost benefit analysis that needs to be done, as Steve correctly points out, and you point out the maturity of the problem needs to be understood and the solutions, and then finally things like mobility and the likelihood that it could go mobile.
And I think that's an interesting dimension that we rarely explore, because we think of the ubiquity of, my phone. The app exists here and in the cloud, and it doesn't matter where I go, it's always universally available. Now, when we add an edge locality aspect, it may be that I go somewhere and only certain things are available to me, but they're relevant to the space I'm in, and they may not need them somewhere else. So it's a different way of looking at the problem space, in the sense that the apps kind of apply to the location, and the location may have specific capabilities that others don't.
Sure, and I've got a couple more quick questions here. One specifically for Director Smith, but people were curious if you could maybe provide some more specific examples of how DoD is implementing, zero trust around hardware. And they asked specifically maybe around testing microelectronic components, to ensure they're free from any kind of vulnerabilities, or how you're looking at supply chain trust.
So simple question, and specifically because I worry about the actual mobility systems and radio and satellite systems, and I have a lot of tactical applications on my belt. I'm not the cybersecurity expert within the department. That said, I can tell you on the zero trust side, we're focusing first and foremost on just the authentication of both the people and the end devices into our networks, and validating when an end device touches our network, it's got all the right patches, it's got the right security, it's got encryption, depending on if it's on one of our classified networks, and then two-factor authentication for the people coming in. And so that is the first part of us working zero trust, and we have a lot of program efforts underway to do both those. The harder part that we're still doing some testing on is the, as I mentioned before, the data and the application, and making sure that we can categorize those. And then if someone has a need to access an application or access a bit of data, that we can then say, does that person have a need to see that data? Is that person a trusted person? If so, okay, we'll let them just see that bit of data. So we're still working parts of that, and we have tests underway for that. The other part of the question, I'm trying to remember, talking about microchips and other stuff. I'm not sure I could even, reasonably address that one.
Yeah, I would say that from the standpoint of zero trust, my perspective is that we've gone a long way in putting the plumbing in place, being able to take away the authenticate to the network and moving into authenticate the endpoints so that we understand the actors. But then the challenge comes into providing the credentials, right? How do you manage an ecosystem of apps and people and all that sort of stuff, and setting the right permissions to scope their access in the proper way is a very difficult problem. So I think it's going to take some time to be able to solve that problem, because it contains a much larger space of challenges, whereas putting in place the ability to do this, I think, is pretty well understood at this point.
And that prompted me to think of one other thing on the credential side of those. As we've been working some of our as a service efforts with industry at a few of our bases, government has unique credentialing. We have PKI, we have a separate CAT card banner, and industry doesn't, and commercial world doesn't necessarily do that throughout. If we had kind of a common standard for doing that across the board, one, it would make things cheaper for the government, because we wouldn't have to continuously build our own government unique systems of authentication to get into the system. If we could trust a commercial marketplace two-factor authentication capability, then I think we would go down that road. But I think there's efforts underway. NSA is working some things with industry to do some of that stuff, but in the future, we're looking to get out of mill standard. We're looking to get out of government unique stuff wherever possible. We want to take advantage of commercial industry, and I think commercial industry has a long way to go yet in standardizing that authentication of devices and people and stuff into a zero trust environment.
Yeah, just real quick on the hardware question. So there may be some solutions out there for which I'm unaware, but I mean, the basic idea to me goes back to kind of the fingerprinting idea. So for example, we have Apple devices. I believe they're still manufactured pretty much solely out of China. But yet we in the government buy them all the time, right? Even though that may fly in the face of the Trade Agreements Act. And so how do we know that some device that, is developed or put together in some other country hasn't been changed? And being able to do hardware fingerprinting, it's almost like what the forensics people do when they go in and they capture something, right? You want to make sure this hard drive didn't change or this file didn't change, so it can stand up in court that, this is really what it is and hasn't been manipulated to make somebody look guilty when they're really innocent, that kind of thing. So we need to get to that point if we're not there, but that's the way you make sure is we got some chips come in and you want to know whether, or a circuit board, there's got to be a means that we need to work on to fingerprint those. We don't have that technology already. So we know that it hasn't been tampered, that nothing has changed. Over.
Yeah, and if I could add to that, this is why Intel and its ecosystem working with the OEMs have been pushing what's called the transparent supply chain, because you can't secure what you don't know. And so step one is to populate what are all the different building block components for a given board, for a laptop, for a server, and be able to give you that BOM in a certificate format so you can verify the quote unquote fingerprint of a particular system. And this is an industry-wide initiative that has been undergoing for a number of years, that we've worked with the large ecosystem providers to the government so that you have that deep visibility into all the components, both hardware and software and the firmware, so that you can verify what you're getting in. That's step one. And then you start figuring out, okay, what do I need to do with that system going on throughout its life cycle, which gets into the life cycle assurance part that I know NIST with its 800-193 has been creating some standards to help the industry universally adopt capabilities to be able to manage the security of that supply chain over time.
Well, thanks for that. And Dustin, I'll turn it over to you for sort of final thoughts from you and your panel.
Well, let me start by thanking you all for your contribution today. I thought it was an outstanding panel. I honestly was about ready to order out lunch for everybody so we could spend another couple hours, but I know you're all a busy team and got lots going on. But again, I just wanted to humbly thank you all for your contribution. I know the audience there had a bunch of questions, so obviously it was a lot of hot topics we covered. I don't know, I'll just open it up to each of you. If you had any parting comments you wanted to provide, go ahead and provide those for us.
I'll go first real quick. I'd like to thank Megan and Dustin, you two, and the Homeland Security Defense Forum for having us, and the audience especially for tolerating us. And there are a lot of good questions out there, and at least I hope that we were able to help answer some of those questions for you and help put you on a good path forward, whether you're private or public sector. Over.
All right, well then I think from my standpoint, I'll leave it as again a thank you to you all. I'm probably reachable one way or another through the forum here. I'm always happy to entertain additional follow-up questions. And would love to dialogue with anybody who has interest in kind of continuing these conversations on. But from that standpoint, I will let my team go here with a virtual fist bump. Thank you again. And we'll sign off for now. Appreciate it.